There are four methods to specify points and vectors in three-dimensional space. And they are rectangular coordinates, direction cosine angles, spherical coordinates, and cylindrical coordinates. The most common type is the rectangular coordinate system. And in the rectangular coordinate system, we just add an additional axis, the z-axis. So for instance, if we define the location of this point here, it will have a three-coordinate location. So we have x, 10, y, 9, and a z value of 4. And so any spot in this three-dimensional environment can be defined with these three coordinates. In the direction cosine angle or the coordinate direction angle coordinate system, the location of a point or vector is defined by the angle that is created between the vector or the magnitude of it coming off the origin so you got a theta x, a theta y, and a theta z. And with all these set would then define the location, in this case A, whose Cartesian coordinates are 15, 10, 5. They can be defined by those angles, which would be theta x of 37, theta y of 58, and a theta z of 74. Okay, well that will be the direction anyway, but not the angle. You still have to specify the magnitude. The relationship between the thetas and the magnitude are given here in this equation, where we have the cosine of x is equal to the component x, ax, divided by the magnitude of a. Okay, so as you can see in this equation, ax, ay, and az all make up the sides of the triangles that would create A. Spherical coordinates are defined by r, which is the distance from the center of the sphere, and theta, which is the angle measured in the counterclockwise direction from the positive x-axis, and the polar angle, which is measured from the z-axis. So if we move A about, you'll notice that the theta, here I'm just changing theta, is changing. Okay, and if I move the polar angle up and down, you can see where that gets changed. So any point on the surface of this sphere can be defined by simply moving it and changing both the theta and the polar angle. And any other sphere can be created by changing the magnitude of r. So you can think of it as layers of an onion, where the layer is determined by r, and then its position on the surface is determined by those two angles. The cylindrical coordinate system is not really used a lot in statics. However, it can help when you have certain geometries. Basically, the cylindrical coordinate system is just a polar coordinate system, but we add a z coordinate to it. So as you can see in this illustration of the cylinder system, you have in the xy plane the polar coordinates, and we add in the additional component of a z.